This is a demonstration of the SeekrFlow user interface from Secret Technologies. It's an end-to-end tool used to prepare data to fine-tune open source models, allow you to test them against non-fine-tuned models, and deploy them, all using a graphical user interface. Here you can see the opening dashboard, where on the left you have the different steps used to prepare the project, a dashboard with quick start options, a listing of my projects. I have many that are underway or completed, and I can also see the status of my deployments, active, pending, failed, and active, along with the number of input tokens I've used. I'm going to use a guideline document from the Government National Mortgage Association Mortgage-Backed Securities, Ginnie Mae. It's 1,600-page PDF with 35 chapters that have guidelines, requirements, and procedures for issuers, including financial, management, and staffing requirements. It covers programs such as single-family, manufactured, or multifamily housing, and also operational procedures such as loan pooling of applications, document custodian, and reporting. The model we're going to build will allow you to ask questions of the contents of this document. We'll move to our sandbox, where we will compare our fine-tuned model with a base model which has not been fine-tuned. In this case, you can see that my fine-tuned model, based on the Llama 3, 8B, and Struct, has been selected and is on the left. The base model I'll select will be the same model, but not fine-tuned, and that'll be on the right. We'll go to our model settings, and for the parameters, just check. We'll see the temperature is set to 0.7, which impacts predictability. Top P is set to 1, which increases determinism. And the maximum number of tokens is 1024. I'll add a system prompt so the model has a better idea of what I expect it to do. I'll copy these parameters over to Model B so that we're comparing apples to apples. And then I'll start to ask questions and see how they perform. First question, what are the key features of the Ginnie Mae mortgage-backed security programs? We'll see answers displayed from each model, and we'll see that the fine-tuned model gives a more brief and succinct answer at 35 tokens compared to the non-fine-tuned model, 507 tokens, much longer answer. Try another question. What is the role of Ginnie Mae in case of issuer default in the mortgage-backed security programs? Our fine-tuned model reports that it guarantees payments in case of issuer default. The non-fine-tuned model gives a much longer answer. Third question, why does Ginnie Mae use issuer funds to cover late payments in the MBS program? Again, a briefer answer, more to the point from our fine-tuned model. Fewer tokens used on input and output. This can be important when you are keeping track of your costs measured in token usage. Another element of the user interface is confidence. We can see the confidence level of each token by flicking the switch and determining which answers are higher or lower in confidence. Darker colors indicate a lower confidence that this is the correct token that's been generated by the LLM. As you can see on the right, the non-fine-tuned model has confidence levels in the teens, in the 60%, where our fine-tuned model has much higher predictability and confidence scores of 99%. So how is this fine-tuned model built? Starting from my dashboard, which again shows my data sets, then my projects, deployments, and sandbox, and finally a model library. I'm going to begin the process to create my synthetic data, which will be used to fine-tune the model. In my directory of data, I've uploaded the 1600-page PDF guide, and then I've started to create the data, which converts it into a Parquet file. When it's complete, it's, in this case, 22,000 question and answer pairs synthetically generated from the PDF to be able to fine-tune the model. Here's a look inside the Parquet file of just 6 of the different lines of the 22,000 question and answer pairs, in case you want to take a closer look at the data that's been generated, maybe add some of your own, maybe subtract some of your own. These are the questions and answers that are one example. I'll go back to my project directory and get ready to create my project. I'll start by creating a run. A run is the process of fine-tuning the model. I'll give it a name and a description, and then I'll select that Parquet file that I generated for fine-tuning. After that, I'm going to pick one of 7 different models to fine-tune against. In this case, I'll use the Llama 3 8 billion parameter instruct model. You can see that we've got a variety of Llama 2 and 3, different numbers of parameters, and different types of models like chat and instruct. Next, I'll select the hardware configuration used to fine-tune this. In this case, I'll select 8 instances of the Gaudi in order to speed the creation of this fine-tuned model. I'm also able to select hyperparameters like number of epochs or passes through the training data set, the batch size, or the learning rate. Before I start my run, I'll confirm that all the elements I've selected are accurate, and I'll agree to the terms and conditions from Meta on using their open source model. I'll start the run, and as listed here, depending on the amount of data being used, it can take anywhere from a few minutes to a few hours. And I can check the status in my run summary. You can see at the top right, the event is queued in the Intel Tiber AI cloud to begin the fine-tuning process. And now I'll check as the run is underway. In this case, I've made it through 1 epoch. You can see that my training loss curve is declining nicely, so that indicates I've got a healthy model, and it's been in progress just a few minutes here. Checking back a little later on, the run is complete. In this case, it took 3 hours. Pretty good sized data set. 10 different epochs that I had selected. Probably in retrospect, I only needed 4 or 5 because my loss curve does not decline much after about 4. Now I'm going to be able to start my deployment of this fine-tuned model. In this case, I've queued it up. The deployment is complete, and I can begin asking my questions. Up at the top is my endpoint. This is useful because if you're a Python developer that's been used to developing code on the front end of your users' applications, not really diving into data preparation, model, and fine-tuning, this is the result that you can point your questions to by using the dialog box in your application front end. This will have saved you the steps of gathering, preparing, fine-tuning, testing, and deploying that you might have had to do in a coding manner. Hopefully this has helped you see how the SeekrFlow user interface can help speed your data preparation and deployment.